we will be finishing the tutorial, the build your own extension tutorial. And then our plan is to mix up the schedule just a little bit. We're going to do the show and tell, and then we'll do the debugging, and then we'll look at how AI can help us write some things. Konstantin's going to show us a lot of the cool experiments he's been doing with AI helping you write extensions. So right now, where are we on the tutorial? We've gone through exercise D, which means we now have this little refresh button here. So what we have right now is we've got our image widget. We've have a launcher item and a command palette item. If we click it, we get the widget. And we can hit refresh, and it'll refresh. You know, picking a random widget, so sometimes we end up getting the same widget, et cetera. But we have a refresh button here. So we've used this area in the main area widget. It automatically gives us this sort of toolbar area of the widget that we can add things to. And so you obviously can add anything you want on a toolbar like that in a main area widget. OK, but we still have a problem. And the problem here is most JupyterLab things, you'll notice like if you open a new window, notebook, et cetera. OK, so you know, here's a notebook, et cetera. I save it, test, whatever, test, rename and save. If I refresh the browser, you'll notice that the notebook comes back, but our image widget is gone. And so how does that, and this is a convention in JupyterLab that if you refresh your browser, then as much as possible, we should preserve your state and your layout and everything. So for example, if we have, you know, another terminal or whatever, and we hit refresh, you know, all of the widgets come back up and they're in the same state so that anytime we consider the browser sort of an ephemeral interface, and when we refresh, we want to get right back to our state. But our widget doesn't have this property. If we, our image widget, if we refresh, it's gone. So the question is, how do we fix this? How do we make it behave like all the other widgets in JupyterLab? And in order to fix this, we use another capability in JupyterLab called the restorer. The idea here is anytime there's a change, we store the state, the current UI state of JupyterLab, and then when you refresh, it'll go back to the server, get that state back to the front end, and then reconstruct that state so that it looks like you're just coming right back into the same session that you had before you refreshed. So how do we interface with those parts of the JupyterLab system is what we're going to do in this part of the tutorial. All right, so this is exercise E. So the first thing we need to do, like with many of the other parts of the tutorial, is pull in a new token, the iLayout Restorer token. This is the part of the system that deals with this saving state and restoring a state after a refresh. So I'm going to go ahead and open up this is in the index.ts. So let's open up the index file. And we're going to import, need the whole line. Right, it's just from the application. So it's already here. I just need to add it in here. So the iLayout Restorer comes with the JupyterLab application. And we need a widget tracker. We'll talk about each of these components in a second. This is in AppUtils. So let's see, where's AppUtils? Right here. And so we need a widget tracker and an iLayout Restorer token. All right, so the iLayout Restorer is going to be the same as the command palette and the launcher, where we want JupyterLab to pass in this thing that causes the restoration to happen. So we're going to, but instead of making it in the requires key, we're going to introduce a new key called optional, which says, hey, JupyterLab, if you have this component, pass it in to me. If you don't have it, just pass in a null to me. This lets us deal with systems that may not have a restorer. And there's various reasons why you might want to add optional functionality. If a JupyterLab application installation doesn't have a particular plugin, you might want to say, well, I want to deal with this plugin if it's there, but if it's not there, like it's fine. I was just going to, I have some other functionality I want to do. Yes, and Matt says, make it a little bit bigger so you can see. So this allows us to just declare optional dependencies that are going to be passed in. So let's go ahead and add this to our activate function, add this to our plugin metadata, and then we'll also add it to our activation function. So right here, now we're requiring JupyterLab to pass in these things, and optionally, please pass in this if you have it available. And of course, add it to the activate function. So the optional dependencies are always passed in last, and they can potentially be null. So that's what we're saying here. Pass in the restorer if it's available, and it'll be either an layout restore, or JupyterLab will give me a null value. All right, so how do we keep track of all the widgets all the image widgets that are there, and their layout and everything? And so to do this, we're going to use something called the widget tracker. This is an object that's available in JupyterLab. It's used for the notebooks and for all the other types of tabs that we have, types of main area activities that we have. We're going to create a new widget tracker, and we're just going to put this in our activate function. Let's see, let's put it where this suggests, right above where we register our new command. Down. Let's see, where are we? Right here, yep. All right, Matt, I also have those extra spaces. Okay, so we're creating a new widget tracker, and we just need to give it a unique name. So we made up a name for it, JupyterCon 25 Extension Workshop. It needs to be unique across the different kinds of widgets that are being tracked by different widget trackers. So Notebook has a widget tracker. Text files have another widget tracker, et cetera. So here we're just creating a new widget tracker. And what this is going to do is it's going to do some automatic listening to when the widget, when the user closes a widget or when it moves it around. It's going to keep track of what's available right now to the user. And then when we create a new widget, we need to add it to the widget tracker. So let's put this right after we create the main area widget. So here we create the main area widget before we add it to the shell. We've got our tracker that we set up here, and we're just going to, if the tracker doesn't already have this particular widget, then we're going to add the widget. All right, and then the restorer. So the restorer, I guess we need to explain a little bit about the restorer, but essentially what we're going to do is when we activate our widget, we need to restore any widgets that were left over from before the user refreshed the page. So when the user refreshes the page, it starts JupyterLab all up over again. All the widgets activate, all the plugins activate functions are called, et cetera. And so what we want to do is restore any widgets that have already been opened before, or right at the application startup. And this is what this is doing right here. Restoring the widget state. And we hand it a tracker, and then we hand a few arguments here. We'll get to these in just a second, but let's go ahead and copy this in, and then down here we'll talk about how this widget restoration happens. So this happens, we're going to do this in the activate function, just at the very end of the activate function. So down here. And we have some extra new lines from the copy. Okay. So how does widget restoration happen? Well, so anytime the widget state changes, it's communicated back to the backend, and somehow you need to store like what widgets are open and where. And then when you restore them, you have to get that information from the backend back to the front end, and then you need to like run this command essentially again for each of the widgets that had been opened before you refreshed. In order to keep track of, hey, how do you serialize your widget state to the backend? And we use JSON by convention. How do you take a widget and like represent it as JSON? And then how do you get that JSON and create a new widget from whatever data that you stored, and then be able to verify that the new widget that's an actual JavaScript object is equivalent to what the JSON data was. And so in order to do this, we're going to give each widget an ID. You see here, actually, each widget is assigned an ID right here. And what we're going to do is we're going to, when the state is saved to the backend, we're going to say, there's an image widget you need to save, and it's ID, and then there's some random ID that's going to be associated with it. And so if we have two image widgets, it's going to save two different image widgets, but each will have a different ID. When we refresh, this restore function right here, that's called when our plugin is activated at the very end of the plugin activation at the JupyterLab startup, it's going to say, OK, I need to restore some widgets, and here's the data, basically, that I need to use to restore, and that's what this is saying right here. In order to restore a widget, run this command, and give it these args. So this is a new concept here, that commands can have arguments. You can see here our command that we added right here. It has an execute function. It doesn't take any arguments. We're going to change this now so that this can take an argument. And this argument will be the widget ID that I need to restore. So the widget ID that existed before I pressed refresh. And I need some way to compare the new object and the data to restore to make sure that they're equivalent, that I did actually restore what I said I was going to restore. And so I have one more function that is any widget, I want you to consider the widget's equivalent if the return value from this is the same. So if I look at two image widgets and I give each to this name function and they return the same thing, then I consider those two image widgets equivalent to each other. And this is how I can tell that, yes, I did actually restore everything that I said I was going to restore. So we need one more piece here, and that is when I restore all the image widgets, it's going to run this command, and it's going to give these arguments to say, hey, not just, I don't need you to just create a new image widget. I want you to create a new image widget with this particular ID that's the same as the ID of the image widget before you refreshed. And so we need some way to tell the command, hey, create an image widget with this particular ID. And so we need to modify the command execute function to take in an ID argument, and if I pass in that ID argument, create a new image widget with that particular ID. And that's what this next block of code is doing. So first, I'm going to change the execute function to take in an args. OK, so any command execute function can optionally take in an args. And args is just a JavaScript object. Think of it like a dictionary. And so this dictionary will potentially have an ID key with a value that's just a string. These question marks mean it's optional. So we don't have to pass the args in. If we do pass the args in, then we're expecting it to be a dictionary with an optional ID parameter. And again, the point here is we're restoring. We have this data that's been saved, that you have two image widgets with ID 1 and ID 2. And so when the restoration function is called, it's going to say, oh, I know I need to run this command and give it ID 1 and ID 2. And it's going to create new widgets with ID 1 and ID 2, and then I can compare those widgets with the information that I have, and yep, the restoration was successful, and I can lay them out however I need. So we've got the ID from these old widgets that's being passed in, and then we need to actually take advantage of it, and that's this block of code right here. Right after we create the image widget, caption, we'll say, if we were given an args to our execute function, and if it contains an ID value, then the widget ID is args.id. Otherwise, it's just, we're going to pick a random ID. So this allows us to recreate the exact image widget that we saved from before the refresh. All right, so let's see if it works, see if all the copy and pasting worked. I guess we need to create a new terminal, activate our environment, build. Give it a second to build. Whew, it built all right. And refresh. This refresh is just picking up our new JavaScript code. And now let's see if the restoration works. So I create a new image widget, and I refresh, and the image widget's still there. Woohoo! And in fact, it's more than just the image widget is still there. If I create a couple of image widgets, let's go ahead and do that, and I relay them out, in some complicated fashion, and I hit refresh, all the image widgets are still there. Now, because that command actually fetches a random image, I might end up with a different image than I had when I refreshed. In order to preserve the image, then you need to also save the information about what image file name, for example. So in the args here, the args are what's saved, what's serialized. We would need to not just preserve the widget ID, but you might preserve like the file name or something like that if you wanted to save more state. The args tells you what state you're going to save, and then when the refresh happens, the command execute function is run again with whatever args that you had saved. And here we're just saving the ID arg, but if you want to save more state for your widget, then you just put it in the args, and then that's pulled back in when you restore, and your command is passed whatever the args are for each of the widgets that you're trying to refresh to restore, and then they come back up. All right, let's see, it worked again. Woohoo, it worked again. But again, because we didn't save the image file name, we're just recreating the widget with the same ID, we may end up with a different cat picture. Okay, let's take a few minutes, let people catch up, and then we'll talk about publishing. So please put a green sticker on your laptop if you're ready to move forward. Otherwise, we'll circle the room for a few minutes and make sure people catch up to this layout restoration part. All right, looking around, there's a lot of green tags. It looks like a lot of people want to move on. There'll be time, if you're behind and you're still trying to figure out, all the steps here, there is time this afternoon for people to work on their own extensions, and we're happy to help catch you up and work through this one as well. The final part that we want to talk about is actually once you've written your extension, it looks really nice, it's got this toolbar buttons, it's interfacing with the launcher, command palette, whatever, it does the state restoration, so it behaves feels like a responsible, well-behaving widget. Now how do you get it to somebody else? And this is the publishing part. And it's really simple at this point. Most of all of these files, a lot of these files are setting up the build process and all this kind of stuff, just the boilerplate templates for you. In order to package, we use the build package for Python. So the first thing to do is pip install build. So let's pull up our tutorial or our example and pip install build. So this is a standard package in Python for building packages. And then it's very simple. Two commands. One builds a source package. Python -, so I should look, you see these directories. When I build a source package, it's going to create a virtual environment, build up the package, package up all your code. What it's doing is it's compiling your JavaScript into a file that we can load into JupyterLab, right? We've been doing that. And then packaging up in a Python package. And you'll notice there's a new directory here, a dist directory. This is what was just created by the build step. So inside this dist directory, you'll see here, in fact, here we'll see here, there's this JupyterCon extension workshop 0.1.0.tar.gz. This is a Python source package. Has all the source files for your Python package. And then recommended for Python is to build both a source package and a wheel package. So let's go ahead and build a wheel as well. This is, again, standard Python packaging terminology and packages. Run these two commands. And as soon as it finishes, in a second, we'll see in the dist directory, there's now a WHL package as well. So WHL is the wheel, and the targz is this Python source package. This is what you need to upload to PyPI. So PyPI is the Python package repository. These two packages are ready to upload. We won't actually upload them today, because no point in polluting the PyPI for just some demos. But if you wanted to try to test it, then in PyPI, there's a test.pypi.org server that's periodically cleared out. It's a good place for testing, packaging, and packaging uploading. We won't go through this step today, but you would just use the standard Python twine command to twine, upload, and then here's where you say upload those two packages that I just created. In fact, you could double check to see if these packages work. We can just create a new Conda environment. I'm going to go back over to my actual terminal here somewhere. I'm going to create a new Conda environment. So this is a brand new Conda environment. It just has JupyterLab installed. Give it a second. Here I'm using Conda, but on my computer, Conda is actually assembling to Micromamba, so it's actually still using Micromamba under the hood. So I'm creating a brand new environment, right? My extension's not installed in this environment. I'm just installing JupyterLab in this environment, and I'll activate it. So now I'm in a brand new environment. JupyterLab's installed, no other extensions are installed, and I'm just going to do a pip install of that particular wheel file that we have here. So pip install, and I just give it the name of the wheel file, which is that thing. So I didn't do the dev install. This is just the built Python package. If I run JupyterLab, now I did the pip install. It installed the extension into the Python environment. JupyterLab's going to see the extension, recognize that it's a JupyterLab extension. This is my new JupyterLab that's running. And with luck, there's our extension. So this is just this is installed from the Python package that I just generated, not from the dev directory that we were doing. So there you have it. Publishing extensions, just a couple of commands, and then upload the PyPI, and you can now share with the world. We've been through a lot, right? There's a lot of steps that we did today, but I just want to go back and highlight a few of the key ideas. One key idea is plugins. Plugins in JupyterLab are the atomic unit for extensibility. And these plugins, every plugin can give back to the system an object to interface with it and to do things with whatever the plugin is dealing with. And it can require those objects from other things. So in this case, we're requiring the plugin objects from the command launcher and the command palette in the launcher, and optionally requiring it from the layout restorer. And this is like the genius of how JupyterLab is extensible, is anything can provide something to the system and interface with other components from the system through this plugin mechanism. And then your plugins can be packaged up into extensions and then installed, and they're automatically sucked up into JupyterLab and automatically instantiated, activated at application launch time. And you can change basically or interface with anything in the system. Any of your plugins, any of your extensions are on the same footing as any other extension in JupyterLab, including all the core extensions. So you're welcome to do anything that any of the core extensions can do. And there's a mechanism for your extension to say, actually, I don't want to just augment the extensions, the current plugins in JupyterLab. I want to replace one or two or whatever. And so you can completely customize this JupyterLab environment through this powerful plugin mechanism. We've seen a few of the capabilities that you can interact with here that come with the core parts of JupyterLab. I'll just point out a good listing. Let's see, if we go to the JupyterLab docs. Here's the JupyterLab documentation, and I think we've pointed at this under the develop extensions and common extension points. Here's a list of a lot of the different things, a lot of the different plugins that you can interface with in JupyterLab. So, for example, the commands, we've dealt with this, right? So, let's see. Yeah, so anyway, here's a list of a huge amount of things in the JupyterLab system that you can interface with. So these are commands. Actually, who asked that question before? This list is a list of commands. And here's the core tokens. These are the tokens that we were dealing with. So lots and lots of tokens that you can deal with. Let's see, some of the ones that we dealt with. Are they listed here? The launcher, the command palette. Command palette, yeah. So for example, here's the command palette token that we dealt with. This is a token that we can require from the system and we can do lots of things with. Here's a list of tons of other things that you can require from the system in order to interface with, to augment, and to call on capabilities with the rest of the system. So this is all in the common extension points in the JupyterLab docs. And then I'll point out one other thing, and that is, if you just search for it, JupyterLab extension examples. And here's a repo of lots of different, here, let's go down to the README here. The idea is kind of like the Matplotlib gallery, a gallery of different kinds of things that extensions can do. So each one of these is a self-contained extension that extends or plays with one part of the JupyterLab system. And so you can see a lot of different examples here of how to add something to the main menu, for example. Somebody had that question. How to add notifications, how to, lots of things in here. Widgets, kernel messaging, command palette, et cetera. So if you want self-contained, small self-contained examples of how to play with specific parts of the JupyterLab system, this extension example repo is a powerful place to look. All right, so with that, I think we're ready to go to the show and tell, which is, the idea here is, okay, now you've got your feet wet in writing extensions, et cetera. You've sort of seen the sort of simplest kinds of extensions you can write. Now we want to jump all the way over to like what's really possible. Like if you spend a lot of time and really want to like do an amazing job with an extension that is like a full-featured, plays with lots of different parts of JupyterLab, like what's possible with extensions? And we've got a few examples of extensions that we want to show you, like what are some of the more complicated extension examples that we have. And we'll start with one of the most exciting areas, I think, in Jupyter right now, which is the Jupyter AI story. How do we play with artificial intelligence and notebooks? And Zach is here to tell us a little bit about this. And Zach is actually leading a huge effort, well, helping lead a huge effort in thinking about the AI story. You'll hear lots of talks throughout this conference from Zach and various other people about the Jupyter and AI story. And Zach is also leading or co-leading a sprint on Thursday. We have sprints all day long, is planning what is the Jupyter AI story, and how do we deal with AI in Jupyter? Zach has some amazing things to show you here.
Okay. Yeah, thank you, Jason, for that introduction. So if you have not met me yet, or I have not met you, my name's Zach Saylor. I am a staff software engineer at Apple. I've been working on notebooks for a long time, longer than I would like to admit. And I do, so I'm going to show you, following the principles and the ethos of Jupyter, which is we tried to create building blocks for interactive computing that then can be snapped together in however way you would like to create experiences, rich experiences for our users. So JupyterLab is just one example of that, right? It's a set of building blocks that come as separate building blocks, but we also ship them as a combined, you can think of it like a Lego set. We ship both the blocks and then the Lego set. And so we want to use that same principle in how we build any features on top of JupyterLab. So we're taking that ethos with bringing the new world of AI into the notebook interface. So into interactive computing, we wanted to provide a way to ship these agents right there in your web experience, same as before. So let me get rid of the toolbars here so you're not seeing stuff like that. So yeah, so how did we do that? So I wanted to share that we do have a couple of talks going on this effort. So there is a GitHub org that is formed that we are trying to recruit people who are interested in working on this problem for the world and get them working in that repo together or in that organization. So I think I have it maybe at the bottom here. So called Jupyter AI Contrib. And you can go to this organization and you can see that this has a collection of repos that are really trying to target a production-ready state, and a bunch of experimental repos where we're starting to explore stuff together and do it in a collaborative way. And really the goal of this org is to provide blocks that can live independently on their own, but then be combined together to ship a whole experience end to end. And it's just using the principles you learned in this tutorial. So I did just start JupyterLab. Let me go find my JupyterLab tab here, okay? And so what this looks like as a starting place is we went and picked an agent that is pretty popular these days. I don't know, how many of you have used Claude Code before? A couple of you? All right, cool. So we wanted to take Claude Code, a really popular agent that exists out there, and make that work natively inside of your Jupyter Notebook environment. And so following kind of the common patterns for doing this in other IDEs or developer experiences, we needed a chat. Right, so we needed a chat interface that we could bring in. Fortunately, there was already work going on here for real-time collaboration on bringing a chat into the interface. And so that's what we have here. So we take the side panel widgets and extend it here to provide a chat interface. We wire this side panel up with a real-time collaboration document in the server. So that's another building block we brought to the system and extended that to bring the chat. It's got simple buttons up top that allow you to name a chat. So let's just create a demo. And you'll see that it provides a little UI down here. This UI is fully integrated with other parts of Jupyter. So again, leveraging that plugin interface, the token interface, and the provider interfaces that you've learned about, you can do things like I could drag and drop into the chat, and now I have appended a file. Or I can click the append, or the attachment and select an attachment from a separate modal. So that's all included here. We've brought the ability for you to discover agents that live on your server. So in this case, we're discovering Claude Code. You can see a Claude Code logo down there. You can select that Claude Code, and this Claude Code has been given tools. So let's just ask Claude Code, what tools do you have available? You can see Claude Code is typing down there at the bottom. And I'm working off conference Wi-Fi, so there's probably going to be some delay here with Claude. Okay, so it came back. And you can see that this comes with the classic Claude tools, like being able to read files and write files and grep files and things like that. But there's also a set of tools that it exposes called list commands, which is how to control JupyterLab commands from the agent, which, by the way, the agent is not running in the server runtime. It's actually running on a CLI. It's being started, and then a Python SDK is talking to it. But it's running on a CLI in a separate process. But we wanted to do things like control the JupyterLab interface. So I could say, what JupyterLab commands do you know? And it will use an MCP interface that we've extended the Jupyter server with to show it the commands that JupyterLab exposes to it. And then you can control those commands through that MCP interface. So you have extensions both on the front end, on the server. So you can see it listed all those commands. Jason was just asking me earlier today, how do we get those list of commands for JupyterLab? Just ask Claude to do it, right? But we can say, Claude, I don't know, can you make this dark themed? And JupyterLab, or Claude Code now knows that it has the ability to call commands in JupyterLab, and it can run those commands from outside through the MCP interface and then trigger a change up in the front end, right? And we can see the interface looks a lot like Claude Code on the terminal, right? It shows you the tools that it called, the arguments it used to pass to it. All that is built natively now in Jupyter. And it can do all kinds of things, right? So write me a demo notebook for JupyterCon. And it will go through a list of tools and capabilities. It'll do a blend of the tools that it knows how to do, like write notebooks using just a on-disk regular notebook edit tool from Claude Code. And then it can open that notebook at the end inside of JupyterLab. It can edit that notebook interactively. And if you stick around tomorrow and you see one of our talks that we have that I showed here on the README, you'll even get, I didn't want to steal the thunder of this talk. Let me just open a preview. But there is a demo where we'll show real-time collaboration with one of these agents. So you'll be interacting with an agent in chat, and that agent will hop into your notebook and then start writing code with you. You'll see the cursor popping across the screen, just like as if it's another human collaborator writing notebooks with you. Apparently, again, I stumped Claude Code on this one. There he goes. It's working slow. It's taking an interesting approach here. But yeah, so the thing to keep in mind here is from an extension mechanism or standpoint, all of this is just using the plugin interfaces, the extension points that are available in the front end to do things like expose commands to the LLM, to create a chat, have that chat have attachments, the ability to add attachments to the chat, the ability to control the notebook from the UI. But there's also backend changes here. We have a server extension that exposes MCP. It speaks MCP because Claude Code, that's how Claude Code leverages tools, is it speaks through MCP to do that. You can also build native agents or SDKs to agents right in your notebook runtime and expose Python tools directly to your agent using some of the tool blocks that we've shown in that other GitHub org. So if you're interested in exploring what's going on in the AI space, it's getting better and richer every day. And there's so many places to work. And so as you start to kind of get more comfortable and more familiar with building plugins after this workshop, come join us over at that Jupyter AI Contrib org, and you'll start to see some of the same extension points that you played with today live in these plugins. And so it's very easy to get in. None of this is forking or injecting anything into the code bases. It's just using extension points, and we can get this rich UX. So we just had Claude Code, which took way too long to write that summary notebook. But boom, it just wrote and opened the notebook that it created right there in the interface and gave me a nice summary of what it did. You can see the tools it called to get there and all the above. All right, I think that's... Feel good?
So I'm going to show an extension called Jupyter GIS. If you've ever worked with geospatial data, maybe you worked with a GIS tool like ArcGIS or QGIS, and these are traditionally desktop applications. They're very complicated, lots of buttons. Think about Photoshop for working with data about the Earth. So Jupyter GIS is a tool like that in JupyterLab. So we created a new launcher icon to create a new GIS project. And now we have a blank GIS project. I'm going to use our layer browser to search for a layer that I can kind of use as our base map. And I'm going to use OpenStreetMap. And this is going to take a second because of conference Wi-Fi. Cool. And let's zoom in on San Diego. And I went on San Diego's geospatial data portal where they've got some public data, and I downloaded a couple files here. But let's start with this kind of global piece of earthquake data before I jump into that. So I'm adding a new layer. I'm making it a GeoJSON layer because that's the format of the data. I'm selecting the data file, and let's give it a name. Okay, and then all our earthquakes show up on the map as little points. But let's say I want to see the magnitude of these earthquakes visualized on the map. So I'm going into our symbology editor. I'm choosing graduated. I'm using the mag attribute of these points, which is magnitude, to color them. I'm going to use the best color map, Viridis, and I'm going to click classify. So now we can see our highest earthquake magnitude is going to be yellow. Our lowest one is going to be dark purple. Click OK. And now we can see, this is a little bit in the way because I'm really zoomed in. Let me zoom out a little bit. There we go. Now we can see all these earthquakes across the planet. But a lot of them are purple. So instead of doing kind of a linear classification, let's change it to based on quantiles, reclassify. And now we can see most of the color map is in these kind of low magnitude areas. And our highest magnitude earthquake is still 8.1, which is bright yellow. And now we get a little bit more differentiation, and we can still see our highest magnitude earthquake is probably this guy over here. And we have an identify tool we can use to view the data of that earthquake directly using a trackball, and it's kind of hard. There we go. So indeed, this is the 8.1 magnitude earthquake. We got a couple other fields here, which I don't know enough about this data to tell you what they are, but one of them here is time. So let's use that time field to visualize this data over time. Let's deselect that one that I selected. Okay, now I'm going to use our time controller, and I'm going to choose a step of a day, and I'm just going to kind of scroll through this data and see where these earthquakes land on which day. And this data isn't, I don't think, correct. I don't know exactly where I got it from, but it's a good demo, I think, if you just ignore these actual timestamps. Let's close our time controller. Let's look at a different kind of data here. I'm going to pull up some of this San Diego data that I've downloaded, but first I'm going to hide the earthquakes by clicking the eyeball. And this extension, well, we'll get to that in a second. Okay, so we're going to look at this hazards data set. I'm going to choose open vector layer, GeoJSON layer, unexploded ordnance. I just thought that was the most interesting, really jumped out at me when I was browsing through the data. Give it a name, press OK. Now we can see a couple of these locations that have been marked with unexploded ordnance in San Diego. And I also want to symbologize that data. So I'm going to make it red. I'm going to give it a yellow outline. Okay, so there we can see those shapes. And I don't know anything about this data, so I'm going to just inspect it. And I can see some information about each of these shapes. This is some sort of artillery thing, mechanized artillery impact areas. I don't know what any of this means. I just downloaded this data yesterday. Okay. Some other stuff we can do is we can view some cloud optimized data. So let's say we want to use this NASA Gibbs chlorophyll data set. We can add it from the layer browser, and then we can see it loaded from the cloud in real time without having to download this data. And this extension is built on top of the Jupyter collaboration extension, which provides real-time collaboration functionality in the Jupyter architecture as an extension. Jason, you want to jump in? Oh yeah, Untitled. I was supposed to name it, but I didn't name it. Still loading?
Yeah. I'm in the demo final section over there.
Oh, you're in demo final. Okay, let's jump into this one.
Annotation for San Diego.
Ah. Okay, so I see an annotation here. Great county for a conference. And I can see down here, there's Jason's cursor. And I think something is broken. I should be able to see Jason's username here, but I can't. Normally I'd be able to click this and follow him around as he moves his cursor and moves his map. And as we edit this data on each of our sides, the other person can see it. So Jason, if you want to like hide some layers over on the left, you can click the little eyeball, and we can see those changes happening in real time.
That's cool.
Awesome. Thanks, Jason. I think that's kind of all I want to show. I'm going to show a little bit more tomorrow at my talk at 11 o'clock if you want to come check that out.
I Hi everyone, my name is Rosio, and I'm going to be sharing Gator with you guys, with y'all. So Gator is another extension. It's a Anaconda environment management GUI extension, and so as you all worked on creating an extension today, as you worked on creating an environment today, you can do that using the CLI, and then Gator is another option for people who might want to work on managing their environments through JupyterLab. You can create environments here. So I was to wait for the packages to load. So here you could see all the packages that are available. You can filter through to those that are installed, and the updatable, it takes a second to load there, but you could also, if you have selected any, let me go back to select, I'll select some and filter through that. You can also create an environment. You can import or create the environment manually. You can name it, let's say, JupyterCon 2025, and you can see down here your environment is being created. You can manage your packages through this extension as well. So if you go to the packages you have installed, if you see something you want to update, you can apply those changes here. Let's say I don't want to do that. Okay, but yeah, this is Gator. There is currently some work being done at Anaconda with Konstantin to revamp the UI and modify kind of the behavior currently, the way that Gator calls Conda. And yeah, if any of you are interested in taking a closer look, feel free. I think this is it for Gator, but I think we're going to be moving on to the debugging portion of the talk. Okay. Okay, so we're going to be going back to the extension working through. So we're just going to talk through some maybe some tips, some things to keep in mind as you're debugging your extension, and yeah, so you might end up spending a lot of your time as you're developing extensions debugging some issues, whether your extension is not building properly, or some API call is not working. So we're going to go over first, like, I guess some types of errors to start off with, and some categories that we have here for errors. We have errors by when they occur. So if you have build time errors, you're compiling your TypeScript and you're trying to build your extension. So oftentimes these can be syntax errors or missing imports. We have some examples there as well of some common issues that you might run into, or some common errors that you might see, like an error. I think these are firstly listed: a missing import, a typo in the method name, maybe a type mismatch, and we'll go through some of these examples a little bit more shortly. So yes, so this is the build time errors. There's also the category for runtime errors, and runtime errors are going to happen whenever you're actually executing your code. So your extension has built successfully, you're now interacting with your extension, but then you see maybe a failed network request, or you're trying to execute some functionality and you see some other error that there's maybe an undefined property that you've been trying to access. So oh, sorry about that. Okay. I hope you can see better. Okay, thanks. Sorry about that. Yes. So for these categories, the build time errors, the runtime errors, you can have build time errors. You'll see the logs in your terminal from the command where you're running JLPM build, and then you have your front-end or your runtime errors that could be from either an error message that you see in the console or an error message that you see in the terminal logs. Another way to categorize errors is are they a Python server error or a JavaScript front-end error? And the Python errors, you'll see it, like we mentioned, from the terminal tab, and something could look like this, a value error where you have an invalid endpoint. And for JavaScript errors, you might see something more along the lines of like a type error where you have a reference to the TypeScript file that is that is the cost. So yeah, just a tip there is to note that sometimes what appears to be a front-end problem is actually something that is taking root in your backend code, your server code. So that's something to look out for. Sometimes you're not processing the data in the way that you might have expected, and so your front end can't receive that data properly. So yeah. The other thing that we can look at is reading stack traces. When you have a JavaScript error, you get a trace back, and that trace back shows quite a bit of output, but sometimes that has the path that sort of the code took before your extension might have crashed. So usually looking at the first few lines of that can give you an idea of where in your code things have gone wrong. Many times the traceback contains references to other libraries that are not necessarily like the root cause of this error. So just maybe scanning that for file names that you find you recognize. One thing to note there is that at times your JavaScript is processed, so it's minified. It has it's sort of unintelligible, so you can't really tell. So one way to identify that is if you see the term bundle.js, you don't see any identifiable file names. You can always double check that your source maps are enabled, so you can see the exact file where things are going wrong in your extension. The next thing we're going to look at here is going to be just terminal and browser. The terminal logs, they are really valuable. You'll get a lot of information from that. Also, when you're building, your Webpack errors will be displayed there. So just keep an eye on that. They're quite verbose. Maybe you've run into them this morning, but sometimes you have to scan that a little bit more closely to figure where the error is coming from. So for browser developer tools, maybe use Chrome and maybe another browser, but you can open your developer tools. I think many of you have been using that today. You can go through some of the useful tabs. We're going to quickly talk about maybe a few of them. There's the console tab, so that's where you would see in red probably some errors or warnings while you're interacting with your extension, and sometimes when you are encountering some odd behavior, the best thing you could do is just to add some log statements and walk through your code and make sure it's reaching certain points, or that you're receiving the data that you expect, or that you're processing that data in the correct way. There's always different types of logs that you can use here. There's log, warn, error, and table, and that can be helpful, as well as you're adding maybe a few console log statements or console statements. You can differentiate them and filter later on to more quickly scan through that. One thing that I will note here as well is that running JupyterLab with --debug can also be very helpful, because you see a lot of output in the terminal side where you can find more information about what errors you might be facing. There's the network tab as well. For API calls, you'll likely make lots of use of this. See error status codes, making sure you're sending the request to the correct endpoints, that your headers and payload are all as expected. And a good categorization is just 200s are usually good. 400 it means something was not found. 404 means something was not found. And then 500, you're looking at maybe some other server error. Yeah, and then sometimes 200 is not always good, because your data at the end of the day could be different from what you need. Then the sources tab as well. This one's really great. You can pause. You can take a look at your code, right? You have source maps enabled when you're developing JupyterLab extensions, so you can put breakpoints and pause and kind of walk through that a little bit. And there's some instructions there on getting started to set a breakpoint. We'll go over that shortly, just really quickly. The other great tab is the Elements tab. So anytime you're looking at the DOM structure, if you're not seeing a button where it should be, or if the styling is off, it's great to interact with that. To modify from that tab, you can apply styling, and you can select elements, view the DOM structure. One quick tip there is that if you at times right-click on JupyterLab, you might see a context menu, so it's great to know that you can just hold Shift while right-clicking, so you can access and inspect that particular element that you're interested in. So this is a quick debugging workflow. Just start simple, console log first, and then move forward. Start using other tools, your dev tools, looking through any tabs that might be relevant, and adding breakpoints. Here as well, like prevention is better than spending some time debugging would be to just have a working extension. So we can use the tools that we have available, TypeScript. Try not to type in any type things correctly or appropriately. That can help us a lot. There's also other tools like formatters and linters that can make sure our code is adhering to a specific style, and also catch typos. That's really helpful. And then, of course, writing tests and error messages that are clear is always going to be nice to reference something that is a little bit more specific than just data in the logs. Yeah. So there's a hands-on exercise here. We can take a look. I have the same file, the widget file that you have all been working on, and we can open that up. I will quickly go through. So the first thing that we'll look at is oh, where did it go? Sorry about that. So the first type of bug is here, a method name has been changed, so we're using this.loadImage, but it's a typo, and if we go to the code, oops. that better? Maybe? Okay. Thank you. Okay. So the first thing you'll notice is that you do have your ID that is being really helpful, suggesting a change to the squiggly lines. It's tempting to ignore, but we can address that. If you tried to build this, you'll see the error message that we were talking about earlier. Here it is, very helpful. Load image does not exist on type image caption widget, suggesting the change. So this, let me see, this can be quickly updated here. We can run build or JLPM build. And if we start it up, let me just double check I don't have it running somewhere else. I did. Okay. So now that it's built, we can maybe see here. Oh, I did have a breakpoint. Oh. Wait, so I added a breakpoint there, but I will refresh and I've taken that out. So we have our extension loaded there. There's not much going on, and we might wonder why that is. If we go to the console tab here, we can see that there's an error message. Here, if we expand, we can see that this is not a JSON response body. If I maybe go to the network tab, I can see here the requests, API requests I was making to a Jupyter server. It has an error 404. If I take a look through here, I can see the payload. Well, actually, so if I take a look through here, I see the endpoint, and let me see. I'll go back to the code really quickly. So if we go ahead and take a look, actually rather than showing my code here, I'll show the code through the sources. So if we look through the source code, where is it? Here it is. You'll see bug number 2 that we've moved on to after building successfully is that the I'm sorry. Oh. Is that good? Is that weird? Okay. Oops. Okay, so it looks like I skipped it. So bug number 2 here is showing that we have the wrong name, and we're using a dot refresh, and so we have widget as any dot refresh. From earlier, you've implemented a load image method, which is definitely not, so refresh doesn't exist, that's not a method, but using any, we have kind of ignored TypeScript as a tool, and we have lost like that knowledge of what are the methods available to us. So if I go back to the code and I change that back to the correct here. So I'm now referencing widget directly, and I can use my ID to say to see that refresh is not a method on the widget. So we can use the appropriate method, load image, and if we actually, let me just say. So once that is fixed, that we have the actual method that we've implemented, then we can look at the third bug, which is the network error that we were seeing as well. That error comes from the fact that we have a bug number 3. Where did it go? Okay, bug number 3 is that we have called the wrong endpoint. We have random image captions here, it's plural, whereas the endpoint in the backend is set to random image caption singular. So in our network tab here, we could see, or I closed it up. Let me see caption. Oh. Okay, so I lost it, but I think we can ignore that. We could build that with the update. We can build. Oh, sorry. Now I will quickly share JupyterLab. So if we launch the extension, we can see where did it go? Okay, there it is. That same the same 404 error that not found, and it's making that call here. If we go back in there and change it back, one sec. Okay, sorry. Line 39. Oh, I see. Okay. Okay. And then we build here. Okay. And we run JupyterLab once more. We will go in there. Okay, now we see our image, and if we wanted to, you saw earlier I had a breakpoint. You can add breakpoints here. If I wanted to add a breakpoint with a URL or URL containing caption, I could see here. You get an indicator. It's paused, and you can walk through. And I think that's the last thing I wanted to share. In the debugging session. I think down below we have some explanation of the bugs. Please feel free to take a look. And we also have other resources, some common debugging scenarios, and links that you might want to visit.
We've had a lot today to think about. I wanted to show two other cool extensions that show how to manipulate and control JupyterLab and kind of what's possible if you're writing extensions for controlling JupyterLab. And then we have a break that starts in like 7 minutes, so this will be quick. The first is something we call the plugin playground. What we realized is, man, it takes a lot of time to write an extension, right? You gotta open a file and all this kind of stuff and publish it to PyPI and have people install it. Wouldn't it be cool if you could write an extension for JupyterLab inside JupyterLab and just load it dynamically? It'd be like its own scripting language inside of JupyterLab, and this is what the plugin playground is. So what I've installed this extension called the JupyterLab plugin playground. Right now it only works for JupyterLab 3. We're working on updating it for JupyterLab 4, but pip installed JupyterLab plugin playground. And the idea is now you can, if you wanted to create a new, very simple extension, it's got a launcher item, just like what we did with our extension that we wrote. You click on this, and you give a new TypeScript file. And you'll recognize this. This looks hopefully very familiar. It's the same sort of thing that we've been writing, right? There's a plugin. Here's the auto start true. Requires valid. Just as a very simple, just add a command that's a toggle. And so you see a few more of the fields that we haven't seen before, and the add command is toggled, and a toggle execute function. But you'll see that if I load current file as extension, it's actually going to take this JavaScript code. I haven't run JLP and build. This is not even a file on my disk, really. It's just a file in JupyterLab, and I'm not like distributing it as part of an extension. It's just the core plugin part of an extension. I load this as an extension. Whoop. I already did load it as an extension. Let me refresh here. Load current files extension, boom. Watch this. Hey, my super cool toggle right here from this extension that I've written inside of JupyterLab, and you can see it toggles, right? Command palette, now it's toggled. I click on it, and now it's going to toggle off. And I click on it again, now it's toggled on, now it shows the state is on. Any of the things that we've talked about where you can speak to a plugin, do stuff, add menu items, whatever, the idea of the JupyterLab plugin playground extension is it makes that possible to do inside of JupyterLab itself. In fact, you can save this script into settings and just have your own little lightweight list of plugins that are loaded every time you start up JupyterLab, or you can share with others. You don't have to write an extension. You don't have to compile an extension. You don't have to publish an extension. You just interact directly with JupyterLab. And the plugin playground essentially takes this code, it does the compilation inside the browser and inserts it into the JupyterLab system. So you essentially have your very lightweight scripting language inside of JupyterLab. This makes extensions so lightweight, you can just use them all day. The other one I wanted to show you is controlling JupyterLab not from within the browser, but controlling JupyterLab from within a Python kernel. So there's another extension. Is Jeremy still here? Yes. Jeremy Toulouse back here wrote this awesome extension called PyPI. And so the idea behind PyPI is it's a proxy between your kernel and the front end. And it lets you execute Python code in your kernel that controls JupyterLab front end. Again, using the same sort of building blocks that we've been dealing with in the extension system. So here's an example. Here's some cool examples from his repo. Okay, so what do? I install this PyPI, so pip install PyPI, and then I'm in a notebook. This is a Python kernel. Remember the architecture of JupyterLab. You've got the front-end browser, you've got the server, and you've got your kernel, Python code running somewhere. I have a new, so from PyPI, I'm importing the Jupyter front-end, and I instantiate it, and my JupyterLab version on the front end is 4.4.10, which I'm seeing in the kernel. This is kind of cool. If you see usually we wouldn't know the JupyterLab version from the front end, but now we're seeing it in the kernel. But even more than that, somebody asked about a list of commands, and Jeremy's like, oh yeah, you could just use PyPI. Well, yeah, here it is. Here's a list of all the current commands in the front end JupyterLab, available in the kernel. Why would you want it in the kernel? Well, because you can run any of these commands from the kernel. So for example here, in Python, I'm going to ask JupyterLab to execute the console create command, and it has a few arguments here. Wham, look at that. I've ran some Python code and updated my JavaScript, my JavaScript application in JupyterLab. I've opened this console. And as we've mentioned before, commands are sort of the underlying way to execute things throughout JupyterLab. Change a theme, done. Run the Python code. Basically, it's sending the code over the command over to the JavaScript, and then JupyterLab is executing as a command. Want to create a new terminal? There it is. Let's see. One other thing. I want to add a menu item. So app.menu.add menu. Okay, let's do it. Here's the menu information. There's the menu that we just added from within Python. It went to JupyterLab, used the building blocks inside of JupyterLab to execute the code here. So in fact, here I can click on this, and you see it actually writes code back into my notebook. And the next one, app.version, the next one actually writes code and then runs it in my notebook. Easy way to provide a front-end interface to getting stuff into your notebook, but executed from the kernel. So anyway, here's some of the crazy things that JupyterLab extensions allow you to do. The brilliance, the genius of JupyterLab is, again, plugins and extensions. Everything's extendable. Every extension is the same as any other extension. Your extension's the same as any core extension. You saw some of the cool, crazy things with the Jupyter GIS and AI and some of these things that people can do with JupyterLab extension system. And what I'm most excited about, I think what we're most excited about is what cool, crazy things do you have that you can take JupyterLab in ways that we would have never dreamed of because you have different use cases and a creativity and imagination that's amazing. So anyway, give it up for the JupyterLab extension system. This is, I'm really excited to see what you invent. Okay, we're at break time. It is 3 o'clock. Break is 30 minutes, is that right? And then when we come back, Konstantin is going to take us on an AI journey with writing extensions using AI.